Well, welcome everybody. Thanks as everybody's getting settled. I'm really excited to have a chance today to talk to you about Snowball. So hopefully a lot of you already saw this in the keynote. But the goal for today's session is to really get an introduction into what Snowball is. Oh, none of these work. Okay, there we go. Okay, so get an introduction as to what exactly Snowball is, what the purpose of it is, how the actual data flow works, and how the service, how you interact with the service. From there, we're going to get into the two most commonly asked questions that I've been hearing over the last day or so here at reInvent that people have been hitting us up with. We're then going to look a little bit in the speed, what that does, what using the Snowball service does for you when you want to transfer large data sets, what the service costs, how the data is secured while it's actually in transit from your site to our site, where we can go and what service destinations are available as we've launched. And then finally, we'll do a little bit of a demo and go through the steps you'd actually go through to actually do an end-to-end transfer. So let's get started on actually introducing the service. So you can see the device here up on stage. That's an actual device. Just go over a couple of the features and elements of the device. So the first thing about the device is its own box. Well, actually, I guess first off, what is Snowball? Snowball is a petabyte scale data transport service. It relies on the Snowball appliance as the sort of central aspect of that service. And the notion behind what the appliance is it's a shippable storage device. So the device is its own shipping case. It is its own label. It takes care of all the logistics for you to sort of simplify that process of getting your data shipped from A to B. So it's ruggedized. It can handle sort of the usual rigors of shipping. The display on the front of the service there, in front of the appliance, is e-ink based. So it is its own label. It can update itself, tell you and the shipper where it's going to go. It also acts as the user interface, like we'll see in a moment here, to help you set up the network and actually understand and use the device. We've done a lot of work to allow the device to operate in the real world, where there's things like rain and dust and all those sorts of things you have to contend with on a loading dock or as it's in transit to you. Also, you have to contend with people. So it's got some tamper-resistant features in the actual physical makeup of the device and in the electronics of the device. What you're actually getting is you're getting a 50 terabyte capacity device with 10 gigabit network out the back of it. So let's go into sort of the overall workflow for how you're interacting with the device. So there's basically four major steps. The first thing you're going to do is go to the console, the AWS console, into the AWS Import-Export Snowball tab. And there you'll be presented with a screen where you can create a job. And the job is sort of the fundamental unit of work for using Snowball. And what will happen there is you'll fill out some data as to where you want us to ship to, where the data is headed, and we'll go through all that in some detail later. Once the job's been created, you can then see the little truck there. The device will be physically shipped to you. When it arrives on your site, what you then do is you download some client software of ours. You configure it with the right credentials that match up to the Snowball device that was shipped to you. And then you can actually then use that client to copy data at high speed to the Snowball device. Once that's ready, all you have to do at that point is turn off the device, unplug it. The return label automatically pops up. You notify the shipper. They pick it up, get sent back to us. And then the final step is that once we get it, we basically do the same process you did in reverse. So we take that box, we plug it into power, we plug it into network, and it automatically gets ingested at high speed up into Amazon S3. So let's go into the two most common questions I've been hearing here at reInvent. The first one that I'm getting pretty often is that you have heard of networks, right? Like, why does this thing exist? And for folks, there's sort of two camps there. There's people who've sort of done or tried to do large-scale data transfers before and people who haven't. And anybody who's really actually tried to do this, it's a lot more difficult than it might seem. So the answer is yes. Yes, I have heard of networks. As the GM for both AWS Import-Export Snowball and the GM for Glacier, I talk with customers on a very regular basis who have petabytes of data. And almost all of that conversation initially centers around how the heck am I going to get this to you? And you do all sorts of network math, and you scratch your head a lot, and you figure out it's going to take a year, and it's still worth it, but it wasn't quite as exciting as it was before, maybe. And there's just a lot of time and effort that goes into that data movement. So for many, many use cases, it just isn't really adequate. And the key thing to recognize is that in your facility, you have all sorts of big fat pipes. In our data center, in our facilities, we have the same, but the transit in between them is typically very, very limited relative to the width, if you will, of the pipes actually in your facility. So it ends up being too slow. It ends up being really inelastic to sort of scale up and down that bandwidth. And just generally, it's quite expensive as well. And so one of the observations we sort of noticed over time here is storage volume is growing way, way faster than bandwidth is. Right? So this is a problem that's sort of accelerating, if you will, in terms of becoming this impediment and this bottleneck. So we've been contending with this for years now as people have been very successfully using networks to send us data to S3 and to Glacier. And I'll say right off the bat that I love networks. Please keep using networks. But for many of the cases where you have a large backlog of data that you want to move, maybe you're trying to retire some existing storage gear and migrate it, perhaps your data is available in large batches. We also deal with a lot of customers where they're air-gapped. They have no connectivity whatsoever, or where they are geographically or worldwide, bandwidth is just enormously expensive. So for those sorts of cases, we really started to think about, well, how could we do this in a different way? And that's where the Snowball concept came in. So fundamentally, the idea is to bring the storage device to the data, right? To connect up to those big fat pipes inside your facility, to ingest data via those pipes as quickly as possible without having to hit the bottleneck that is the internet, and then to be able to parallelize that, if you will. So you're basically taking it from your facility into the Snowball as the first step, Snowball into us as the second step once you've shipped it to us, and repeating and parallelizing as necessary. So where you have a 10 gig connection and 50 terabytes of the single Snowball, if you bring 5 of them on site, all of a sudden you have a 50 gig connection and 250 terabytes of capacity that you can rapidly transfer data to. So you can imagine, again, when you sort of think of network topologies where it tends to fan down to that bottleneck and then fan back out, there's no need to do that really. You could actually connect up to your switches and still speak via your network or via your DMZ or what have you to your end storage devices. But for folks who have the ability to parallelize, it's also quite possible to just take the Snowball and connect it directly to the machine you're trying to take data from, and to do that for many machines. So you can keep this in sort of large-scale parallel transfers. So that's question one. The second question that I'm getting a lot also, and this is, I'd say, I probably should have done this in the other order. This is the most popular question we're getting at the booth is, can I drop it? And I'm gonna say no on that one. Please don't. And the reason for that is, we actually spend a ton of time on this because you basically have to design the device so that it can handle that sort of thing, right? So that it can handle sort of some of the expected worst case things that can happen to it in shipping. It falls off the back of the truck. It falls off the loading dock, all those sorts of things. But we really prefer you didn't do it, even though it was designed for it. We've done many, many, many drop tests on the Snowball already from sort of every angle that we could over and over and over, put it on shake tables for sort of days at a time. So we know that it can handle the normal stresses and impacts of shipping, but we'd ask that you don't experiment with that yourself. I can lift it, but first let's actually drop it. Okay, so I'm not going to drop this one, although it's on sort of a teetering table here, but we will take a look at a video here. So what you're about to see here, this is one of the drop tests that we performed a couple weeks back, where this is I think a 6-foot drop onto concrete, and you can sort of see a nice bounce here. So that's our fella, and you can see that it held up pretty well. And if you sort of look at the device, and if you kind of peer, maybe when you come to the booth or after the talk, I'd invite you to take a closer look. You'll find this mostly foam, right? And so there's sort of a foam structure, protecting the inner electronics, inner guts of the device. And then we've actually had to do quite a lot of isolation within the device itself to make sure that it's actually usable after that drop. So this isn't something you really want to do with a normal storage device. What you'll find is like boards will separate, things will crack, cords will come out. It ends up being sort of much more fragile than you might think to try and ship these around under normal circumstances, and especially repeatedly. So, and somebody asked about lifting it. So that's actually a good point. So the other thing that we sort of thought about and contended with as we were designing the device was we wanted to make it single-person usable. So that means it has to be light enough for one person to actually be able to use it. We didn't want to have it operate in exotic environments. Even though a data center isn't terribly exotic to most of you. We wanted to make sure it could run on standard wall power, standard networking, and it was sort of useful in most contexts that people were going to actually sort of try and use the device. So let's look at some of the speed advantages that we can actually achieve from this model. So First, let's take a look at what you can do with Snowball. So when you think about getting the device actually on site, you have the 50 terabytes in that 10 gig connection. You're actually able to fill the device within about a day of it being on site if you're able to drive 10 gigabytes. So that's really nice and quick, but that's sort of a bit unfair because we also have to account for shipping on either side of it. So it's about 2 days to ship, 1 day to fill, 2 days to ship back, and then we need a day to then pump that data back up to S3. So about a week, a little less than a week, end to end, if you're able to drive it at sort of full capacity. And you can compare that to typical connections, internet connections, right? And so what you have here is you have a variety of sort of fairly standard internet connections you'd find from your business, anywhere from 150 megabytes per second all the way up to, say, a gigabit per second. And then different utilizations, because the other kind of key thing to recognize here is that you're not necessarily going to be able to use 100% of your connection just devoted to whatever the large data transfer is that you're trying to do. So at the high end here, if you can only devote, say, a quarter of your connection and you have a 150 megabit per second connection, it's going to take you about 4 months to send that data, to send 50 terabytes worth of data over your network. On the other hand, if you have a gigabit per second, you can do it in a little less than a week, so it's about comparable to what Snowball can do. So where this gets really interesting is then when you think about, again, that parallelization use case, right? Although there's also the fact that you're just not actually using your existing connection, which presumably is being used for other tasks. But the moment you're looking at parallelizing, let's say we used 5 Snowballs. Again, now we can move 250 terabytes of data in the same amount of time, assuming we can parallelize at the source. Whereas on our internet connection, now on the high side, we're almost up to 2 years. And in the best case, we're a little over a month. Right? So this can really accelerate just how quickly you can move a large-scale data load from your facility to us, which we're really excited about, and we've gotten some really good reactions from the preview customers we've worked with so far. The other key thing that always is coming up as we're looking at Snowball with folks is how are we actually transporting the data securely? Right? Like, is this just going to sort of wander off? What happens if the shipper loses the box, which can happen? What happens if it goes to the wrong place, which can happen? So fundamentally, what we do there, or what we rely on there, is digital security. And the model is that you never actually write data directly to the Snowball. You write data via the Snowball client, and the Snowball client then encrypts that data on your local host before ever sending it to the Snowball device. So data landing on the Snowball is encrypted at all times. The second key bit is keys are never kept on the Snowball or ever sent to the Snowball at any time. So we have integration with KMS, which is Amazon's key management service, where you can use a default key or create your own key, and that's what will actually be used to encrypt the data on the Snowball side when it's on your site, and then to actually decrypt the data once it arrives back in our facility. Once the Snowball arrives back in our facility, we don't actually even decrypt the data until it's well into our service stack as well. So it's never coming across the wire as decrypted data. The other thing that we have to contend with is some measure of physical security, right? People might be intercepting this, expecting this, and we wanted to do some work there. So the first thing that we do is we maintain a strong chain of custody over the device. So you know where it is at all times. You know who has the device. We've done a lot of work on the case itself to make it tamper resistant. Now that, of course, is never going to save you if somebody takes a hacksaw to it. So really we're relying on the cryptography. But there's some good work there, along with making sure that we're doing tamper-resistant electronics, so it has a TPM module built into it. And then between each use of the Snowball, between each job, we're sanitizing it according to NIST standards. In terms of where the data can go, at launch, we're supporting import to Amazon S3 in both the US East 1 and US West 2 regions, so Virginia and Oregon. And the idea there is that once you're in S3, you can then fan out to any other service, right? So you can take it to Glacier or EBS or wherever your final destination might be. Over time, we'll of course be expanding to include other features such as export, which we have a lot of excitement around as well. And then other service destinations, so you can go direct to Glacier, direct to EFS, direct to EBS, places like that. And then other regions, of course, worldwide as well. Let's look a little bit at the cost. So I already mentioned that it's $200 per job. And the idea there is that that $200 is meant to be sufficient such that for most use cases, that's really all you're paying plus the shipping of the device. So for that $200, you're getting 10 days of having the device actually on your site. So we're not counting the shipping days on either side of that. And that's generally enough to be able to fill up the device using a 10 gigabit per second connection or a 1 gigabit per second connection within that time frame. If you want to keep the device for longer, that's fine as well. It's just $15 for every additional day than you have it on site if you need longer to complete your transfer. What we found there as we worked with customers in the preview was that by and large, what was driving the need to hold the device for longer was really the speed of their source data. So another feature that we built into the client that we'll talk through a little bit on the demo is the ability to actually test how quickly the source is able to provide data to the Snowball device. So you can run the client in sort of a test mode where you don't actually even need a Snowball, and we're just seeing how quickly we can sort of ingest when your Snowball actually arrives. Beyond that, you're charged for standard S3 request charges, storage charges that you incur, and then it's 3 cents per gigabyte to transfer data out and free to transfer data in. So let's look at a couple examples of that. So in the first example, if you just say had 40 terabytes, then you could fit it, and you wanted to import that to S3, you could fit that all in a single Snowball. Let's say that you had a 10 gigabit per second connection, so you're able to finish in 2 days. Then it'd just be the $200 plus shipping. In the second example, let's say you had a bit of a slower connection, or you weren't able to fully utilize your connection for whatever reason, and you wanted to transfer 30 terabytes, then you'd be paying that $200 per job for the single Snowball, plus 2 times $15 a day for $230 plus shipping. In the third example, this is an example of parallelization. So if you had a larger data set and you needed to load, let's say, 140 terabytes onto 3 Snowballs, you could do that serially, one Snowball after another, or do that in parallel. It's going to be the same cost. So in this example, we're doing 140 terabytes onto 3 Snowballs and having it, say, take 8 days. That would just be 3 times $200 per job, one job being each one of those Snowballs that arrives at your facility. And then the final example of an export, so if you're to say want to export 30 terabytes onto a Snowball, and you only took, say, 8 days to fill the Snowball, that would be $200 for the job, plus 30 terabytes times 3 cents a gigabyte for the export, so you're looking at just over $1,100 for that job, plus the shipping. So let's do a little bit of a demo. So getting back to our overview, right? We had our four sort of major steps, if you will. Creating the job, connecting to the Snowball, doing the data copy, having it shipped back to us, and then having us actually upload the data to S3. So let's start off on the creating a job step. So what you're going to do here is you're going to go into the console, click the Create a Job button, and you have to give us a little bit of information so that we know where to ship the Snowball. So you can create a new address for us to ship the Snowball to, or use an existing address, and then choose your shipping speed. So by default, we do 2-day shipping, but if you want 1-day shipping, that's available. Once that's created, you give us a bit of detail about what you're actually going to be doing with the job. So give your job a name. At the moment, the only destination service is S3, so that's there by default. Tell us what region you want the Snowball to go to. At the moment, again, Virginia or Oregon. And then add buckets. So you need to tell us which of your buckets you actually want to be able to get data to the Snowball. So you can add 1 or more buckets here, and those will actually show up, you'll see in a few steps from now when we're actually doing our data copy. So in this case, we've just added a single bucket. Then we actually need permission to do this. So in the next step, you need to create an IAM role for us. It's just a one-click process. Say create IAM role, and then say allow. And that just gives us permission to essentially access your bucket once we actually have the Snowball back filled with your data. And then you can choose your key. So you can choose a default KMS key for encryption, or you can create or choose one of your own keys. And then the final step on the creation process is notification. So this again gets back to a bit of chain of custody and knowing where and what's going on. So you can create an SNS topic or use an existing SNS topic and have us email you at any step of the process you choose as to when the device shows up, when it's actually finished importing, when the job's complete. And at that point, your job is ready to go. So now that the job's been created, you now basically can wait for your Snowball to arrive. So it should get there within the shipping time period. And what you're going to want to do there while you're waiting for it is then get the client ready. So you can see a link up at the top here where it says download client. So you can download the client. We have clients available for Mac, Windows, and Linux. And you can download that, get that installed on the machine you're going to be copying data from. And actually, you can do 1 or more machines. And then wait for the Snowball to show up. Then the Snowball shows up. It'll look like this. The flaps will actually be down typically when it arrives. So it'll sort of look a little bit more like this, just for protection for the actual device itself. So at that point, what you would do is you'd open up the flaps. They just nest on top. You have a coil of cables on top for power and 2 types of network. So we support RJ45 and SFP+. Plug it into power, plug it into network. And then at that point, you're going to see the e-ink display on the front change from your shipping label to the configuration label, or to the configuration mode. So there, what you're going to be able to do is set up your network. So in this one, we've sort of grayed out the IP, but you notice the RJ45 and the SFP+ there. You can have both of those connected. And what you're going to do there is, if you already have DHCP and you had power in while you were connected to the network, it's going to do a DHCP lookup, try and get an address. If that fails, you can go in, or if you want to, it can go in and configure a static IP. So once the Snowball has an IP, the next step is to then get the credentials that you need for the client to talk to the Snowball. Right? This is unique for every single job. So you go into View Job Details in the console, and you'll be presented with a bunch of detailed information about the job, along with the credentials for that job. There's sort of 2 key pieces of information that you need there. You need a job manifest file, which contains keys and metadata related to your job, and you need an unlock code. So you get those 2 pieces of information, and then you're going to run the Snowball client. So from a terminal, you then first have to start the Snowball client to establish a secure connection from your client machine to the Snowball. So in this example, what we're doing is a Snowball start, and we're passing it the IP address of the Snowball, so it's exactly what you'd find on the front label, on the e-ink label, the path to the manifest file, and then the unlock code. And if that's successful, you're then going to be establishing that secure connection to the Snowball, and you're ready to copy data. So second step, and there's a lot of other commands that you can do as well here, but this is sort of the kind of key normal step then, is to point the Snowball client at your data source and copy it. So what we're doing here is a Snowball copy. We're doing a recursive directory copy of the /log/April directory, so that's our source data, and we're pointing it at the S3 bucket that we chose, right? So in this case, S3 : my bucket logs April. If you had multiple S3 buckets that you specified back in that job creation step, all of those would be available as destinations you could copy to. So you could do also a Snowball ls and see what's on the device, what buckets are on the device. And that's basically it. So at this point, what you'll be presented with is a status bar showing how many files have been copied, what the speed is, and sort of you're able to track the process of that copy. What the client's actually doing for you here is a couple of things. So the first thing that it's doing is it's doing a highly parallelized copy. So it's breaking up files, doing multiple copies in parallel so you can really get the most out of your actual network connection. Turns out that's actually a really non-trivial task. And then the other thing that it's doing is, of course, encrypting the data before it ever actually hits the Snowball. Once that's done, what you're going to do is you're going to basically take the Snowball, coil back up the wires, turn it off. It's unplugged, I guess, because you coiled back up the wires. And then your screen is going to automatically go back to our shipping screen. You just notify UPS at that point to do a pickup, and the Snowball gets shipped back to us. From there, what you can do is then look at the console, track the progress of the Snowball job, so it'll go from in transit to importing to complete. And once it's complete, view a report on what it was actually done so you can handshake and understand that your data actually made it. One important thing to think about here is that this is data in transit. You sort of have to treat it like a network transmission. So you want to make sure the data actually arrives intact at us before deleting the source copy of the data or doing anything like that. And at that point, you've done a transfer. Again, you can sort of stamp this out many, many times if you're looking for more throughput. And we hope you have a lot of fun importing data. So thank you.